All right, so this is reviewing the second derivative, concavity, and the second derivative test. So if I want to know the concavity here, and I want to know the point of inflection, I need to take the second derivative. So I'm going to take the first derivative, and then after taking the first derivative, I'm going to take the derivative again. That's going to be the second derivative. And then at this point, I'm going to make it equal to 0, and I'm going to solve it. So there's only one answer. That's a critical number for the second derivative. That's 1. Then I'm going to draw a number line. I'm going to put that number on the number line, go back to the second derivative, plug in a number smaller than 1, and it's negative. Plug in any number bigger than 1, it's positive. So we know it's concave down from negative infinity to 1. We know it's concave up from 1 to infinity. And then at 1 is a point of inflection because the concavity changes. So then I plug 1 into here, and it's 2 take away 6. Negative 4 plus 1, that's negative 3. That's done. All right, second practice. How about finding where the local minimums and maximums are using the second derivative to help us? So this is a second derivative test. But first we need to find the critical numbers of the first derivative. So we're going to take the derivative, and we're going to make it equal to 0. We're first going to do that. So I'm going to divide everything by 3. I hope this works out. I'm going to factor it. I hope this works out. And then solve it. So I get two critical numbers at negative 3 and 1. Now, instead of drawing a number line, I'm going to do the second derivative. That's 6x. That's 6. That's 0. And then I'm going to plug the critical numbers into the second derivative. And I'm just caring if the answer is negative or positive. That tells me concave up or down. That tells me if it's a maximum or minimum. So plug in negative 3. It's a negative answer, concave down. That means at negative 3 is a local maximum. I'm not in the mood, but if I needed to, on the quiz I think it only says the x value. So then you could just say that. So at x equals negative 3 is a maximum. You'd have to plug it back into the function to find the y coordinate. Then the other one, which is 1, plug that into the second derivative. You can see the answer is positive. That's concave up, which means it's a local minimum at x equals 1. That's it. All right, let's do well on that quiz. Mr. G Math, over now.